Hey everybody, good morning, good afternoon, good evening, depending on whatever time you're watching this, whatever time it is. I hope you're having a great day. Today we're going to look at how to solve proportions, so let's go ahead and get started. So I just realized that I feel like I need like some intro music or something to go at the beginning. So if you can't be copyrighted, obviously, so I can't use regular music that you guys just like to listen to. But if there's someone in band or someone that just likes to play music that wants to put a little 5, 7, 8-second melody together for me that I could use for my intro, that would be fantastic. All right, so let's take a look at solving proportions using algebra. All right, so we have the question on the left that says Pamela drove her car 87 miles. Her car told her that she used 4.3 gallons of gas. She wants to know how many miles she can drive with 12 gallons of gas. She wants to know how far she can get on her full tank. She's got a little bit small car. Only holds 12 gallons of gas. So let's first of all set up a proportion. Now right now we're not going to worry so much about how to set these up. We'll have a future lesson we talk about writing and creating our own equations. But once we get it set up, we'll talk about how to solve it. So she says she drives 87 miles, so I'm just going to write down 87. That represents my miles. And she gets 87 miles for every 4.3 gallons used. So I can just put 87 miles for every 4.3 gallons used. Now I want to know when that is going to be the same as so many miles. Now I don't know how many miles they are, and so in this problem they said we're going to use m for miles. So we'll put m up here for miles. Now again, we don't know how many miles, but we do know that it's 12 gallons of gas. And so we get a proportion that looks like this. 87 over 4.3 equals m over 12. Now one of the things we'll do when we get to creating equations is realize the denominators are both of these represent gallons. The numerators both represent miles. You want to set up proportions that way where you're comparing the same things on the top to the same things on the bottom, or something similar to it. There's other ways to set up proportions, and we'll talk about those. At this point, what we're going to talk about, though, is just how would we use algebra to solve this problem. Now, I realize that there are other ways you could solve this without algebra, so we're just going to use this time, though, to talk about how algebra could be used to solve it. In this case, we want to solve for m, so m is up here on the top. We're going to try to just use our same solving rules as before, so who's bothering the m? Is this divide by 12? To get rid of a divide by 12, our inverse operation is to multiply by 12. Multiplying by 12 on that side allows us to cancel that out. And to be fair, to be equal, to keep it equal on both sides, if we multiply by 12 on the right side, we're going to multiply by 12 on the left side. Now when we're multiplying by 12, we're not multiplying both of these numbers by 12. If you want to think of it as a fraction, 12 is 12 over 1. So we're really just multiplying the 12 by 87, and then we're going to divide by that 4.3. At this point, on the right-hand side, m is by itself. On the left-hand side is a little different. On the left-hand side, we still have some math we can do. So it says 12 times 87 divided by 4.3. You could do the 87 divided by 4.3 first on a calc, and then times by 12, or you could take 12, multiply it by 87, then divide by 4.3. Either one will work. So I'm going to take 12, I'm going to times it by 87, and then if I want I could hit enter here, or I could just hit divide by 4.3, and it tells us that our answer would be 242.79. We'll just round that to the nearest mile and do 243 miles. So if she had 12 gallons of gas and it was proportional, she could go 243 miles on 12 gallons of gas. All right, we just finished up with a problem where we had to solve for how many miles we could go in a 12-gallon tank. This one wasn't too bad because our m was in the numerator, and it allowed us to easily get rid of a divide by 12. And so we could quickly do that, get a problem that we could solve algebraically, and have our answer fairly quickly. What we're going to look at in our next two examples are proportions that are set up a little bit different that make it a little trickier and allows us to have something, or we can kind of learn a trick that makes them a little bit simpler, and that's called cross-multiplying. But we're going to talk about why we can cross-multiply, so you don't just apply it in situations where you shouldn't, because it's really easy to get confused. So let's say I want to solve a proportion that looks like this. 7 out of something. We don't know what it is, so we called it m. is the same as 8 out of 9. So 8 out of 9, that's pretty full. So what would that be? Would that be the same as 7 out of 8? Well, it should be a little bit smaller than 7 out of 8 to be the same proportion as 8 out of 9. To help us solve that, we're going to solve for m using our algebra. Now what we find is when m is on the bottom, like here in the denominator, it's a little bit harder to get m by itself because we got to think about how it's attached to what's attached to this. And normally we would say, well, it's a times 7 or a plus 7. Well, we know that it's not a times 7 attached to the m because a times 7 would look like this. And we know our m is not getting divided by 7 because if it was getting divided by 7, the m would be on top. So I can't just multiply by 7 or divide 7. It's certainly not addition or subtraction. So when we have the m on the bottom, how do we get that to get it by itself? And what we do in problems that look like this is we say, well, having the m in the denominator is tough to solve. So let's just get it out of the denominator basically by moving it. Because it's a divide by m, I can get rid of it here by multiplying by m. So if I multiplied by m, that would get rid of not just the m on the bottom, but also the division sign, and just leave me 7 on this side. But if I multiply by m on one side of the equal sign, to keep it equal, we're going to have to multiply the other side by m. So that's like multiplying it by m over 1. And so when I multiply that, I get 8m, 8 times m, still divided by 9. And if I want to solve that, maybe I want to get rid of this divide by 9 because that is what's bothering the m now, and it's farthest away. So to get rid of a divide by 9, I would multiply by 9. And so I could just multiply both sides by 9, and I end up with 9 times 7 equals 8 times n. 9 times 7 is 63. 8 times m is 8m. Now, cross-multiplying allows us to kind of skip this step. If we understand why we're doing it, then we can apply it correctly. I don't know if you noticed or not when we did that problem, but what actually happened is when we have a proportion, so two fractions equal to another fraction, one fraction equal to another fraction, and we want to solve, one of the things we can do is we can just multiply in diagonals. So I can multiply the 8 times m together and set it equal to the other diagonal. That's why they call it cross multiplying. We're multiplying across the diagonals and set them equal to each other. The reason that works is to get rid of a divide by 9, I need a times by 9. So on this side, we're going to get a 9 times 7. To get rid of a divide by m, I'm going to times by m. So I'm going to get an 8m. So if you ever see a proportion, fraction equal to a fraction, we can always multiply the diagonals because basically all we're doing is getting rid of the divisions. And so that becomes a lot easier. We get 7 times 9 is 63, set it equal to 8 times m, and now we can solve it really quickly by dividing by 8. Taking my calculator, taking 63, dividing it by 8, I'm sure we'll get a decimal. 63 divided by 8 is 7.875. So in this case, m is equal to 7.875. Now that again works anytime we have a proportion. So not that we need to do this one completely, but if I gave you another example, let's say it said 4 over x equals 3 out of 7, and I wanted to solve it, I could just start by just multiplying the diagonals and set them equal to each other. So 3 times x is 3x, and I'm going to set that equal to the other diagonal, 4 times 7. Now the product of the other diagonal, I got to multiply them together because I got to get rid of that divide by 7. So 7 times 4 is 28, and then if I wanted to solve it, I would just divide by 3. So that becomes a nice, easy way to solve problems that are set up as proportions. We could have even done that on this problem at the beginning. We could have did 4.3 times m equals 87 times 12, but then we would have had one more step to solve. So I usually don't use that if there's a single m and it's on top. I usually use the cross multiplication. Even though it works in both cases, I usually use it when my variable is on the bottom. We're going to finish up just looking at one more example where cross multiplying can really help. Hey, if you're still here, I just want to say thank you so much. Congrats. Good for you. Way to stick with it. We have one more example to do, and then you guys can start practicing some on your own. So let's go ahead and get at it and get out of here. All right, let's say we're asked to solve a proportion that looks like this. This one looks a little bit different than the rest of ours. This is definitely where cross multiplication will come in handy and allow us to solve this problem a lot easier. So we have x plus 6 over x. So I'm thinking of a number that if I added 6 to it and then divided by that same number, it would be equal to having 4 out of 7. And so when we solve this, because it's a fraction equal to a fraction, or what we call a proportion, we can multiply the diagonals together and get a brand new equation that's easier to solve. Again, we can do that because if I want to get rid of a divide by x, I'm going to multiply by x. So if I do that with this diagonal, I multiply the 4 by the x, I'm going to get 4x. And then if I set that equal to the other diagonal, just like before, if I wanted to get rid of a divide by 7, I'm going to multiply by 7. Now here I got to be careful because who am I multiplying by 7? It's not just the x and it's not just the 6. It's both of those. So when I write that, I'm going to write out 7 times the quantity x plus 6. Now if you understand what we're talking about there, you could multiply these and put that answer right here. So you could have just went, well, I know 7 times x is 7x, and 7 times 6 is 42. You could have just started right there. Or you could write it this way, 7 times the quantity, then distribute. You would get the same answer. 7 times x is 7x, 7 times 6 is 42. On the left-hand side, we still have the 4x. Here we got an equation with variables on both sides. Normally with variables on both sides, I say get rid of the smaller one because it gives us positive x's. But this is a good case of saying it's not a rule. You don't always necessarily want to apply that rule. If I subtracted 4x from this side, there would be nothing left here. Then I'm going to have to move the 42 over, which is possible, but I'm going to take 0 minus 42. I can save myself a step. If I notice, if I get all the x's over here, then I'll just have numbers over here. So if I want to get this x or get rid of this x, so the x's are on the same side of the equal sign, I want to get rid of a positive 7x. So to get rid of a positive 7x, I'm going to subtract 7x. On my left-hand side, 4x take away 7x. That gives me negative 3x. On the right-hand side, the x is canceled out, and I get 42. At this point, I just have to divide by that negative 3. Dividing by negative 3 on both sides, I believe will give me a negative 14. Let me just double check. You can always use your calculator to check if you like. 42 divided by negative 3 is exactly negative 14. So I get x equals negative 14. And that would be the end of that problem. So we can use, when we're solving proportions, we can use algebra, and we can even use shortcuts if they're proportions and just know that we can cross multiply because we can see getting rid of divide by x and divide by 7 is the same as multiplying the other side by those numbers. I hope that made sense. If it doesn't, please just email us. Let us know. We'll definitely help you out, get you guys all set up. Good luck on your practice problems, and we'll see you soon.